Well, now we're going to compare data using histograms. And so we're asked to use a graphic calculator to construct a histogram for each set of data. And let's see, we've got a second period class. So this teacher has surveyed his class, the population of his class, to determine how far away from the school do they live. In other words, what's their average, what is their length of their drive time in minutes? And we have here some data for the second period and his seventh period class. Now, I've gone ahead and graphed these, as you can see. This is the histogram for the second period. This is the histogram for the seventh period. And we can tell, it says describe the shape of the data. Well, they're both skewed. And that means that, let's see, well, this one is positively skewed. Let's say the second period is positively skewed. And the seventh period is negatively skewed. Based upon our histograms. And I went ahead and didn't do it. I didn't go through the calculator. I've got some other videos where we've shown how to input the data and then create the histograms. So we have described the shape of the data. Let's take up the second part of this. And so here it says, compare the sets of data using the means and standard deviation, or the 5-number summaries. Well, if we're comparing the data using histograms or box and whisker plots for that matter, if they were both symmetric, we would use the means and standard deviation. But if just one of them is skewed, we use the 5-number summaries. And in our case here, in our example, they were both skewed. One was positively skewed, the other was negatively skewed. And it's kind of interesting when you actually sit down here, and I've gone ahead and put the 5-number summary. It's kind of interesting what you kind of come up with and some of the conclusions that you may reach. Well, both the second period and the seventh period have a minimum of 4 minutes from the classroom. So they have the same minimum. These are the shortest distances in minutes to the classroom, to the school. But we can see here on the maximum, the second period goes as long as 33 minutes, while the seventh period is 26 minutes. And then I look here at this median, 13 minutes for the second period, but the Q1 is 13 minutes for the seventh period. And what that means is that half of our data, half of the students in the second period live within between 4 and 13 minutes from the school, where only 25% of the seventh period lives between 4 and 13 minutes. Or I could go the opposite way and say that 75% of the students in seventh period live 13 minutes or further or longer away from the school, where only half of the students in the second period are longer than 13 minutes. And then I notice the median here for seventh period is 19. So on average, the members of the class in the seventh period live longer. In other words, there's 50% or 19 minutes or shorter, let's say, versus second period 13. Half the class is within 13 minutes of the school. But out here, the Q3s are about the same, 22 and 21. So we got a wider range. The range for second period, let's see, 33 minus 4 is 29. And the range for second period is 22 minutes. So our data is a little bit more compact in the seventh period. This would indicate they're short, the class with a median of 13 that they live less distance in minutes from the school, but our maximum's way out here at 33, 7 minutes longer than the maximum. So here's my question for you. What conclusions would you reach in evaluating these 5 number summaries?